Ohm's law, named after the German physicist George Simon Ohm, who studied the relationship between the voltage, current, and resistance. That relationship leads to the statement of Ohm's law, which says that the voltage across the resistance is equal to the product of currents passing through it. The resistance is directly proportional to the voltage and inversely proportional to the current, meaning when the resistance increases, the current decreases, and when the resistance decreases, it brings the current to increase its value. This can be proved mathematically with some examples. In the following example, we have a resistance of 1 kilo ohm with a voltage of 15 volts. To find the current value, Ohm's law formula will be used, which is the voltage is equal to the product of current and resistance. Therefore, the current will be equal to 15 volt over 1K, which is 15 milliamps. By decreasing the resistance from 1K to 330 ohm and the same voltage of 15 volts applied, the current will be equal to the ratio of 15 over the resistance of 330, which is 45.46 milliamps. By increasing the resistance from 1K to 3.3K with a given voltage of 15 volts, the current will be equal to the ratio of 15 volts over 3.3K, which is 4.54 milliamps. By looking at all these calculations, we easily see that the higher the resistance, the lower the current, and the higher the current, the lower the resistance. After talking about the theory part of this project, let's see now how this principle can work practically in engineering field with an electronic circuit. The building of used in the previous calculation, which are 1 kilo ohms, 330 ohms, and 3.3 kilo ohms. By definition, a resistor is an electronic component playing a primary role to limit current till a certain point in order to protect the circuit. We need the power supply, which is a device that powers or provides voltage and current to a circuit. We also need the multimeter, which is an instrument for measuring voltage, current, resistance, and some other units. Then we need the breadboard, which serves to build circuits on. So in this project, the power supply is needed to give us 15 volts that we've measured in order to power the circuit. We need the resistor of 1 kilo ohm, 330 ohms, and 3.3 kilo ohms measured. Now with the multimeter on ampere scale, we're going to measure current through each resistor to prove what we saw previously. First, with 1 kilo ohm resistor, we've got 15.40 milliamps. When we took the lower resistor of 330 ohms, we've got 46.5 milliamps. Then when we took the higher one, 3.3 kilo ohm resistor, we've got 4.58 milliamps. Now we can see that the measured and calculated values of the current for each resistor are approximately the same. For 1 kilo ohm resistor, 15 milliamps as calculated value and 15.40 milliamps as measured value. For 330 ohms resistor, 45.45 milliamps as calculated value and 46.5 milliamps as measured value. For 3.3 kilo ohms resistor, 4.54 milliamps as calculated value and 4.58 milliamps as measured value. To summarize what has been done in this project, grade 11 learners should understand that calculations done at school can be applied easily in practical. So instead of running away from math and science, grade 11 learners have to understand that nothing is easy in life, only hard work is required. Love math and science, work hard at it, and you'll make it.